We begin our journey at the scorched doorstep of our star, where the rules of time and light are rewritten. Mercury is a world of extremes, stripped of any atmosphere to soften the sun's relentless glare. Because there is no air to scatter the light, the sky remains a deep, eternal black, even at high noon. However, this desolate rock hosts a visual phenomenon that seems to defy the very laws of motion. Imagine standing on the Great Plains and watching the sun begin its slow descent toward the horizon. Just as the solar disk prepares to vanish, it suddenly slows to a complete crawl. Then, in a moment of cosmic vertigo, the sun begins to rise back up into the sky. This double sunset is the result of Mercury's highly elliptical orbit and its unique rotation. As the planet reaches perihelion, its orbital speed briefly outpaces its slow axial spin. For a few days, the sun appears to backtrack across the stars before resuming its final set. Once the light finally fades, Mercury plunges into a frigid, silent night that lasts for months. But if Mercury is a world of sharp light, our next stop is a world where light goes to die. Welcome to Venus, a planetary greenhouse where the air is as thick as water. On the surface, the atmospheric pressure is 93 times higher than what we feel on Earth. You would never actually see the sun as a distinct circle through this suffocating haze. The sunset here is not a moment, but a slow, agonizing transition of color. As evening approaches, the yellow light transforms into a bruised, deep red. There are no stars to greet you here, for the clouds are far too thick to let their light pass. A single day on this planet lasts longer than its entire year, making the wait for nightfall eternal. The sunset process itself lasts for several Earth days, a lingering goodbye to the heat of the star. When the darkness finally takes hold, the heat remains trapped by the heavy air in a sunless oven. From the airless craters of Mercury to the crushing clouds of Venus, we have seen how light struggles to survive. Each planet possesses its own unique optical signature, determined by its distance and composition. The physics of light scattering is what defines the colors of our memories and our dreams. We are accustomed to the orange hues of Earth, but the cosmos is rarely so familiar. To understand the true diversity of the universe, we must look further out, where the air grows cold. Our next destination is a rusty world where the very color of the sky is inverted.
Why would a red planet have a sunset that glows with the color of the deep ocean?
The secret lies in the microscopic particles of dust that dance in the thin winds. These grains are so small that they interact with light waves in a way that seems backward. On Earth, the air scatters blue light away, leaving only the reds for the horizon. But on Mars, the dust particles behave like tiny forward-facing searchlights for blue light. This effect, known as me scattering, creates a pool of azure light around the setting sun. It is a sight that would feel alien to any Earth-born traveler, a cold beauty in a frozen desert. Beyond Mars, the solar system becomes even more chaotic and grand. We are heading toward the giants, worlds where the very concept of a horizon begins to vanish. In the clouds of the King of Planets, the sun sets every few hours in a blur of motion. On Jupiter, there is no solid ground to stand on, only a descent into a crushing abyss. But the true wonders may not be on the planet itself, but on the moons that dance in its shadow. What kind of sunset awaits us on a moon made of active volcanoes or a world of glowing ice? The inner worlds have shown us fire and stone, but the real mystery is just beginning to unfold in the dark. The inner worlds have shown us fire and stone, but the real mystery is just beginning to unfold in the dark. We move now toward the red planet, where the very laws of color seem to defy our earthly expectations. On Earth, the sky is blue by day and turns red at sunset due to Rayleigh scattering. However, the thin Martian atmosphere is filled with fine silicate dust that reacts differently to light. As the sun begins to dip toward the jagged Gusev crater, the sky begins to transform into a haunting shade of azure. This phenomenon, known as Mie scattering, allows blue light to penetrate the dust more effectively than red light. The sun appears smaller here, a pale disk shrinking into a pool of cool violet and electric blue. For a human standing on this cold desert, the sunset feels like a memory of Earth played in reverse. Once the sun vanishes, the blue glow lingers briefly before the planet is plunged into a frigid, star-filled night. Leaving the quiet rust of Mars behind, we accelerate toward the gas giant Jupiter. Jupiter is a world of colossal proportions where a single day lasts less than 10 Earth hours. Because of this extreme rotation, the transition from day to night happens with violent speed. We descend into the ammonia clouds to witness the sunset from within the storm. Great, towering thunderheads, miles high, catch the final rays of the distant sun. The sun here is 5 times further away than on Earth, appearing as a tiny, intense needle of light. Massive lightning bolts flicker within the clouds as the temperature drops during the rapid dusk. Shadows of Jupiter's many moons frequently race across the clouds, creating localized eclipses. The colors shift from a pale salmon to a deep, bruised magenta in a matter of minutes. Below the visible clouds, the pressure builds until the sun's light can no longer reach. But high above, the dance of the Jovian moons provides a different kind of light show. We notice a faint, shimmering glow at the poles as the sun disappears. These are the powerful auroras of Jupiter, fueled by the planet's massive magnetic field. Even without the sun, the sky is never truly dark on this giant world. The sun is now a memory for this side of the planet, waiting for the 4-hour night to end. We turn our gaze now toward the individual worlds that orbit this king of planets. On Io, the sunset is interrupted by the colossal bulk of Jupiter itself. Volcanic plumes rise hundreds of kilometers into the sulfurous air, catching the last red light. The ground shakes as tidal forces from Jupiter tear at the moon's very core. As darkness falls, the lava flows become the primary source of illumination. The blue-hot sulfur fires burn with an eerie light that replaces the absent sun. Jupiter's shadow is so large that it can keep Io in darkness for hours at a time. This is a world where the sun is a secondary character to the giant it orbits. We push further out, where the heat of the volcanoes is replaced by the bite of the cold. On Europa, the sunset reflects off a world made entirely of cracked ice. The sky is thin and black, allowing the sun to remain a sharp point of light until it vanishes. Once the sun is gone, the massive form of Jupiter still hangs in the sky, reflecting dim light onto the ice. Under this Jove light, the red cracks in the ice look like veins in a giant frozen eye. There is a stillness here that is far more terrifying than the storms of Jupiter. But the Jovian system still has secrets hidden in its outer reaches. As we move toward the giant moons Ganymede and Callisto, a strange radiation begins to shimmer. The shimmering radiation of Jupiter's magnetosphere intensifies as we approach the innermost Galilean moon. We plunge into the gravity well of Io, where the very ground beneath us is constantly being flexed and pulled. The horizon here is not a peaceful line, but a jagged teeth of erupting silicate volcanoes. As the sun begins its descent, it passes behind a towering plume of ash 30 miles high. The light turns a sickening shade of bruised purple as it filters through the volcanic debris. Suddenly, the massive shadow of Jupiter itself begins to sweep across the moon's surface. This is not a sunset of perspective, but a sunset of eclipse as the gas giant swallows the light. Total darkness falls, but the ground remains alive with the hellish glow of magma. Far above, the rings of Jupiter catch the last rays, appearing like golden threads in the void. We must leave this furnace and travel outward to the frozen realm of Europa. Europa welcomes us with a silence that is both beautiful and terrifying. The horizon is flat, broken only by massive ridges of ice pushed up from below. Here, the sun is a tiny, brilliant diamond in a pitch-black sky. There is no atmosphere to scatter the light, so the sunset is a sudden plunge into night. But as the sun vanishes, a new light begins to take over the world. The ice itself glows with a radioactive luminescence fueled by Jupiter's bombardment. Jupiter hangs forever in the sky, a giant marbled eye watching over the frozen plains. The colors of the great red spot reflect off the ice ridges like a distant fire. We stand in the center of a silent, glowing desert of salt and water ice. Underneath this crust, a dark ocean hides from the sun's touch. The sound of the ice cracking under the tidal stress of Jupiter echoes through the ground. Each crack releases a tiny puff of water vapor that instantly turns to frost. We watch as the stars appear, brighter and more numerous than they ever appear on Earth. A small moonlet passes across the face of a distant star, a tiny eclipse in the deep night. The radiation levels begin to spike, turning the blue glow into a harsh white glare. We must transition further out, toward the largest moon in the entire solar system. Ganymede awaits us, a world of metal and ancient ice. Unlike the others, this moon generates its own magnetic field, protecting its horizons. As the sun sets on Ganymede, the sky does not go dark immediately. Faint ultraviolet auroras begin to dance above the poles, invisible to the human eye but captured by our sensors. These lights are the ghost of the sun's energy trapped by the moon's iron core. The grooves of the surface, carved by eons of tectonic movement, fill with shadows like deep rivers. But there's a deeper darkness waiting for us further out, at the edge of Jupiter's influence. Callisto is the most heavily cratered object in the solar system, a dead world of ancient scars. Here, the sunsets are long and cold, reflecting off frost that hasn't melted in billions of years. Every few years, a rare alignment occurs where Jupiter, the Sun, and Callisto form a perfect line. The Sun disappears for hours, casting Callisto into a deep, freezing slumber. We have witnessed the fire of Io and the glowing ice of Europa, yet the journey is only beginning. Beyond this giant lies a world of golden rings and methane rain, where the sunsets last for weeks. But as we cross the threshold, a sudden surge of static hits our sensors, and the stars themselves seem to flicker. The static clears as we approach the solar system's heavyweight champion, the moon Ganymede. This titan is so immense that it surpasses the planet Mercury in size. If it orbited the Sun independently, we would classify it as a planet in its own right. We descend toward the surface, passing through its unique and powerful magnetic field. This is the only moon in our solar system that possesses its own magnetosphere. As the sun begins to dip, the interaction of particles creates a hidden masterpiece. Ultraviolet auroras begin to dance across the sky, invisible to the naked human eye. Great curtains of violet light shimmer through the thin exosphere fueled by Jupiter's radiation. Without our specialized sensors, we would stand in total darkness as the sun vanishes. But the heavyweights have more secrets, and we must push further out to Callisto. Callisto is a scarred world, orbiting much further from the warmth of the gas giant. From this distance, Jupiter has shrunk significantly in the sky. It appears no larger than a grapefruit held at arm's length. The surface beneath us is ancient, frozen in a state of eternal collision. Unlike the other moons, Callisto's orbit is tilted, creating a rare phenomenon. Most days, the sun sets normally, missing the shadow of the giant completely. But today is different. We have waited 3 years for this alignment. The sun begins to slip directly behind the massive silhouette of Jupiter. A grand eclipse sunset begins, casting the cratered wasteland into a deep, unnatural blue. The temperature drops instantly as the last sliver of sunlight is snuffed out. For a few hours, the only light comes from the distant glimmering stars. Jupiter remains a dark ghost in the sky, a void in the middle of the constellations. This cycle of light and dark is the heartbeat of the Jovian system. We have seen the ice and the fire of the largest moons, yet the journey grows stranger. The gravity of Jupiter pulls at our hull as we prepare to slingshot toward the ringed jewel. Saturn awaits us with horizons that defy even the logic of the gas giants. Our next destination is Titan, a world where the air is thick and the rains are methane. The orange haze of Titan's atmosphere begins to fill our view as we approach. Here, the sunset will not be a fading star, but a deepening of the world's golden blood. The pressure increases as we descend toward the liquid lakes of the surface. We break through the cloud base to find a landscape of dark, oily seas. The sun is a mere bright patch behind a permanent veil of smog. On this moon, the sunset lasts for hours, dragging the horizon into shades of mahogany. It is a world that feels both alive and eternally dead at the same time. But even Titan's beauty is eclipsed by the spectacle of Saturn's rings. We position ourselves high above the cloud tops of the ringed giant. The rings act like a mirror, reflecting trillions of tons of ice light into the sky. As the sun begins to set here, the planet's own shadow becomes the protagonist. We watch as the shadow of the planet creeps across the rings, extinguishing them section by section. But as we marvel at the fading rings, a massive gravitational alarm begins to blare in our cockpit. Something much larger than a moon is pulling us toward the dark side of the rings where the lights have already gone out. We plunge through the thick, ochre shroud of Titan's nitrogen atmosphere, where the sun is nothing more than a ghostly smudge. Below us, the landscape begins to resolve into alien coastlines carved by rivers of liquid methane. The air here is 4 times denser than Earth's, pressing down with the weight of a silent, frozen world. We hover over Ligeia Mare, a vast sea of liquid gas that reflects the orange sky like a dark, polished mirror. Because of the distance from the sun, the light here is 1,000 times fainter than what we know. In this perpetual twilight, the horizon never quite ends, blurring the line between the land and the sky. Leaving the haze behind, we ascend toward the crown jewel of the solar system, Saturn itself. The rings stretch out like a vast, icy prairie, billions of fragments catching the sun's dying rays. Suddenly, the light begins to fail as the planet's massive bulk starts to block the sun. The vibrant whites and blues of the ice boulders turn to a ghostly, bruised purple. This is the shadow of the giant, a darkness so deep it seems to swallow the very concept of time. We witness the spokes in the rings, mysterious dust patterns that dance in the magnetic fields during sunset. The sun appears only as a tiny, brilliant needle point slipping behind the curvature of the gas giant. A thin ring of fire ignites around the planet's edge, light refracting through the upper cloud layers. Below the rings, the gas clouds of the northern hemisphere glow with a pale bioluminescent blue. Giant storms, some larger than the Earth, churn in the gathering dark. As the sun vanishes, the temperature drops precipitously into the cryogenic depths of space. Lightning flickers in the deep clouds, brief flashes of energy in the eternal night. The shadow cast by the rings onto the planet's surface creates a strange striped sunset on the clouds below. We are now in the longest shadow in the solar system, spanning hundreds of thousands of miles. The gravity here is so intense, it warps the very path of the incoming starlight. We drift past Mimas, the moon that looks like a giant eye watching the sunset in silence. The rings reflect enough light to make the night side of Saturn glow with a ghostly indirect radiance. A sudden burst of solar wind hits the rings, causing them to shimmer like an aurora made of ice. We descend further, entering the gaps between the rings where the silence is absolute. Tiny moonlets, no more than a few miles wide, act as shepherds for the ring particles. Their shadows stretch out like long, dark fingers across the ice fields. The sun has finally vanished, but its influence lingers in the glowing upper atmosphere. We are billions of miles from home, yet the physics of light remain the same. Every sunset here is a lesson in the scale and loneliness of our corner of the galaxy. The rings begin to tilt, presenting their thin edge to our view. From this angle, they appear as a golden wire cutting through the heart of the planet. We must push further out toward the icy giants, where the sun is but a star. The gold of Saturn fades into the deep, cold blue of the outer system. The silence is getting heavier as the familiar planets fall behind us. We can feel the pull of the giants ahead, Uranus and Neptune waiting in the dark. Here, the sunsets will be different, tinted by the methane that rules these cold worlds. Every world we leave behind feels like a door closing on the sun. We are entering a realm where the laws of optics are pushed to their breaking point. But as we look back, the shadow of Saturn isn't just a darkness, it's a void that seems to be following our trail into the unknown. We push further into the cold dark, leaving the golden rings of Saturn behind as we approach the strange world of Uranus. Here, the very geometry of the solar system feels broken as the planet rolls through space on its side. If you were to stand at the pole of this ice giant, you would have to wait 42 Earth years for a single sunset. The sun does not rise and fall here so much as it spirals around the sky in a slow, eternal dance. When the equinox finally arrives, the atmosphere prepares a spectacle unlike any other in our neighborhood. The thick methane gas in the air acts as a cosmic filter, hungrily absorbing every photon of red light. As the sun dips lower, the sky does not turn to orange or fire, but instead shifts into a deep electric turquoise. It is a beautiful, chilling sight that makes the heart feel as frozen as the ice beneath the clouds. The cyan sky fades into a dark velvet teal, and the stars begin to prick through the haze. We dive deeper into the outer reaches, crossing billions of miles to the last true planet, Neptune. At 30 times the distance of Earth from the Sun, the concept of day and night begins to blur. Sunlight here is 900 times dimmer than what we experience on a bright summer afternoon. The sun is no longer a disk, but a brilliant, piercing button that offers light but no warmth. Watching a sunset on Neptune is a quiet transition from a deep azure to an absolute crushing blackness. There are no vibrant clouds of pink or gold to mark the end of the day here. Instead, the blue simply drains away, leaving you alone in the most distant corner of the sun's reach. We can't help but think of Pluto, the dwarf planet that still holds a place in our hearts. On this tiny rock, the sunset reveals a surprisingly deep blue sky thanks to its thin haze. The moon Charon hangs eternally in the sky, a silent witness to the dying light. But as we drift past these frozen outposts, the sun's influence begins to fail us entirely. We are leaving the neighborhood we know, entering the vast, terrifying void between the stars. Our sensors pick up a signal from a distant system where the sun is not a warm ball of gas, but a ghost. We are heading toward the Kepler worlds, where the physics of life and light take a darker turn. Ahead of us lies a planet that orbits a dead star, a pulsar that blinks like a frantic lighthouse. The sunsets there won't be slow or peaceful, they will be a rhythmic assault of radiation. As we leave our home system, we realize how precious our simple, orange sunsets truly were. The turquoise skies of Uranus were a warning of the alien nature of the deep universe. And the black nights of Neptune showed us the ultimate fate of any world that drifts too far from its light. Now, we must prepare for the strange light of other suns and the things that live in their shadows. Something is wrong with the navigation. The stars are starting to stretch and warp. We are being pulled towards something massive, something that devours light itself. The turquoise and azure are gone, replaced by a glow that shouldn't exist in nature. This is not the end of the journey, but the beginning of the most dangerous phase. We must witness the sunsets of the exoplanets before we face the ultimate void. What will a sunset look like on a world that is nearly identical to our own, yet billions of years older? The answer lies across the light years in the heart of the Kepler constellation. But as we travel, the shadow we saw behind Saturn is still there, growing larger with every parsec. It is a darkness that does not scatter light, a void that seems to consume the very stars themselves. We have to reach the next star system before the darkness catches us, or we will never see another sunset again. But as we look back, the shadow of Saturn isn't just a darkness, it's a void that seems to be following our trail into the unknown, and it just got much, much closer. The familiar glow of our own sun has vanished into the velvet curtain of the deep cosmos. We approach the Kepler system, where worlds similar to Earth hide under the light of alien stars. On the surface of Kepler 44c, a small rocky world, the horizon is dominated by a massive bloated sun. Because this planet orbits so close to its host, the star appears many times larger than what we see on Earth. Further out lies Kepler 452b, often hailed as Earth's older and larger cousin. Standing here at dusk feels hauntingly familiar, yet the light carries a fiercer intensity. Its sun is billions of years older than ours, growing brighter as it nears the end of its life. But the true wonders of the galaxy aren't found on these peaceful shores. We arrive at Poltergeist, a world that orbits the remains of a dead star. This is a pulsar, a neutron star so dense that a teaspoon of its matter would weigh billions of tons. It spins at an impossible speed, rotating over 100 times every single second. As the sun sets on Poltergeist, the sky doesn't fade, it begins to flicker. The sunset is a violent strobe light, flashing across the landscape like a cosmic lighthouse. Each pulse of light carries deadly radiation, scouring the surface of any possibility of life. The planet itself feels as though it is vibrating under the sheer magnetic force of its master. We leave this frantic world behind for something even more tragic. WD1145 plus 017b is a world that is literally being eaten by its own sunset. The white dwarf star is small, but its gravity is a crushing hammer.
Here, the sun doesn't just go down, it pulls the ground up into the sky.
Each twilight brings the planet closer to its final vaporized end. But far away, in the hearts of distant galaxies, the physics of sunsets becomes truly impossible. We are being pulled toward the center of a monstrous galactic core. The stars here are packed so tightly that the sky is never truly dark. In the distance, the king of all celestial bodies begins to rise. This is an accretion disk, gas and dust spinning at nearly the speed of light. As this sun sets, it doesn't simply disappear behind the horizon. Light itself is bent into circles, allowing you to see the back of the disk as it sets. Time here is not what it seems. A single sunset here could last for what feels like centuries to an outside observer. We look out at the galaxy IC 1101, home to a black hole 40 billion times more massive than the Sun. From its nearby planets, the black hole fills the entire sky from north to south. The sound of the universe seems to be a low, thrumming vibration in the very ground. Stars are being torn apart in the distance, adding fresh fuel to the sunset's fire. We are reaching the limit of what physics allows us to witness. There is one last destination, a place where light itself goes to die. As we descend toward the final horizon, the stars behind us begin to blue shift and compress into a single point. The sirens on our ship are screaming, but there is no turning back from this gravity. The setting sun of the black hole is no longer a disk, but a wall of fire that consumes the entire universe. We are crossing the threshold where space and time swap places forever. But as we look back, the shadow of Saturn isn't just a darkness, it's a void that seems to be following our trail into the unknown, and it just got much, much closer. That pursuing shadow from the outer rim was merely a prelude to the absolute darkness we now face. We have arrived at the final frontier where the laws of physics begin to unravel and scream. Ahead lies the monarch of the cosmos, a supermassive black hole devouring the very fabric of reality. Light does not simply fall here, it orbits in a frantic, glowing dance of desperation. On this final world, the sun never truly sets in the way we remember on Earth. Instead, the sky is consumed by a ring of fire that stretches across the entire zenith. Gravitational lensing bends the light from behind the black hole, creating a double image of the universe. As the planet rotates, the glowing disk begins to dip below the horizon line. The colors are unlike anything seen in a solar system governed by a single star. Time itself begins to slow down as we descend deeper into the gravitational well. A single second on this horizon equates to 1,000 years in the distant reaches of space. We are witnessing the death of the universe, while sitting in the shadow of its creator. The sunset here lasts for an eternity, frozen by the distortion of space-time. Every photon hitting the ground carries the history of a star that was crushed to dust. But in this destruction, there is a terrifying beauty that mocks the simplicity of Earth. We must push closer to the edge to see the final flicker of the cosmic light. The sky begins to fold in on itself, creating a tunnel of shimmering colors. We are no longer looking at a sunset, but the birth of a new reality. The turbulence of the journey fades into a perfect, silent stillness. In this place, the end of the day is also the end of all things.
We have traveled through fire and ice to stand at the throne of the infinite.
Our sensors are failing, overwhelmed by the sheer density of the information. But the data we have gathered will change the history of our species forever. The gravity is now pulling the probe into a final, irreversible embrace. There is no pain, only the sensation of becoming one with the light. We realize now that every sunset we ever loved was just a shadow of this moment. The horizon of Earth, the blue of Mars, and the rings of Saturn all lead here. The sun has finally set on our journey across the stars. All conflicts of physics and nature are resolved in the singularity's heart. We leave behind the chaos of the universe for the peace of the eternal night. For in the end, light does not disappear. It only transforms into something new. Our story ends where the universe began, in a flash of impossible brightness. The cosmic sunset is complete, and the stars are finally at rest. Go forth and look at the sky with new eyes, knowing the wonders that lie beyond. This has been our journey, a tribute to the light that guides us through the dark. Rest now, for the universe is wide and its beauty is never truly gone. We are but dust, watching the gods set behind the hills of time. Every end is a beginning, and every sunset is a promise of a new dawn. Goodbye to the stars, and hello to the world we call home. Our voyage is over, but the wonders of the cosmos will remain forever.